Okay, this video goes over some famous window function using the notations that I typically use. All right, so uh, in this example, m is the length of the window, and so the first famous window function is the Bartlett window, which I'm going to denote as w underscore b of n, or w sub b of n, and it's equal to 1 minus 2 times the absolute value of n minus m minus 1 over 2 divided by the quantity m minus 1. And what that gives me is a triangular function which ranges from 0 at 0 and 0 at m minus 1 up to a maximum value at m minus 1 over 2. So for example, if I plugged in m minus 1 over 2, then I would have 1 minus 0. That's going to give me a magnitude of 1. All right, this is simple, but it's not very effective in reducing the F-domain ripples. So instead, let's try windows that are based on the Gaussian function. And the reason for that is that when I take the Fourier transform of a time domain Gaussian function, it looks like a Gaussian function also in the frequency domain. And so we're going to go to values that look similar to that. And so the first is what we call the Blackman window, which I'm going to denote as w sub bl of n, which is 0.42 minus 0.5 cosine of 2 pi n over n minus 1 plus 0.05 cosine of 4 pi n over n minus 1. And so it's going to look something like this. And then the other version is the Hamming window, and these are actually very similar. The Hamming window, w sub h of n, is going to equal to 0.54 minus 0.46 cosine of 2 pi n over m minus 1. So they're both going to look somewhat Gaussian, and these might be very effective in reducing that F-domain ripple that you get if you use a rectangular window.